In the previous video, we looked at how to judge whether a carbon credit is genuinely credible. We explored concepts like additionality, permeance, leakage, and verification, the principles that help us evaluate the integrity of a carbon credit. But those principles become much clearer when we understand one important thing. What kind of project is actually generating that carbon credit? Because behind every carbon credit, there is a real-world project, and different types of projects come with very different strengths, risks, and climate impact. So in this video, we'll break down the main types of carbon credit projects and understand what's really behind the credit. Before we go further, it is important to know why project type matters. It is important to note that all the carbon credits are not the same. One carbon credit may come from protecting a forest that keeps carbon locked away. Another comes from capturing methane released in landfills, turning a potent greenhouse gas into usable energy, and preventing it from escaping into the atmosphere. Another source is a facility, for example, futuristic-looking facility with large fans, that directly captures carbon dioxide from the air, locking it away instead of letting it accumulate in the atmosphere. Each of these operates differently, each has different costs, risks, and climate impact. Which means, to understand carbon markets, we must understand what's behind the credit. Now it's time to look at the two big categories that define how carbon credits work: avoidance and removal. One prevents emissions before they happen, the other pulls carbon back out of the air. First, let us take a look at the avoidance credits. For example, renewable energy replacing coal power, energy efficiency improvements, preventing deforestation. Removal credits, on the other hand, come from projects that actively remove carbon dioxide from the atmosphere. For example, tree planting, soil carbon sequestration, direct air capture. This distinction is important because avoidance reduces future emissions. Removal addresses existing emissions already in the atmosphere. Both are vital pillars of climate strategy, each serving a distinct purpose in how we plan, prioritize, and act to cut emissions and restore balance. Now, we look at the different categories of project. Category number 1. Nature-based projects. One of the most widely known categories is nature-based solutions. These projects use natural systems to absorb or store carbon. For example, number 1. Reforestation and afforestation, planting new trees or restoring forests helps absorb carbon dioxide, locking it away as the forest grows. Number 2. Avoiding deforestation, which means protecting existing forests prevents massive carbon releases that occur when trees are cut or burned. Number 3. Mangrove restoration, which means reviving coastal mangroves captures carbon in dense roots while shielding communities from storms. Number 4. Soil carbon projects, that involves improving farming practices that stores carbon in healthy soils, boosting fertility and resilience. These projects are attractive because, number 1, they support biodiversity. Nature-based projects protect habitats and species, strengthening ecosystems while capturing carbon. Number 2. Provide community benefits that involves creating local jobs, improving livelihoods, and often delivering cleaner air and water. And, number 3, are relatively cost-effective. But they also raise important questions around permanence, what if forests are lost, measurement accuracy, and leakage. Another major category focuses on renewable energy, powering progress with cleaner, sustainable sources. These projects generate credits by replacing fossil fuel-based energy. Examples include vast wind farms that harness moving air, solar installations capturing sunlight, and hydropower projects that use flowing rivers to generate electricity, delivering renewable energy while reducing reliance on fossil fuels. The idea is simple: if clean energy replaces coal or gas, emissions are avoided. These projects played a major role in the early growth of carbon markets. However, today they are often debated because many renewable projects are now commercially viable on their own, which raises questions about additionality. The next category, methane and industrial projects, targets non-carbon dioxide greenhouse gases like methane, one of the most powerful drivers of climate change. Typical examples include capturing methane from landfills. In this, methane gas is collected from the landfills and used as an energy, preventing emissions and reducing climate impact. Number 2. Waste-to-energy projects. Non-recyclable waste is converted into clean energy, reducing landfill use and generating electricity sustainably. Number 3. Methane capture from agriculture. In this, methane from livestock waste is captured through anaerobic digesters and used as biogas for clean energy. Number 4. Industrial emission reduction technologies. In this, advanced technologies reduce emissions from industrial processes, improving efficiency and minimizing environmental impact. Methane is a much more potent greenhouse gas than carbon dioxide in the short term, which means reducing methane can have a significant near-term climate impact. These projects are often considered high-impact, technically measurable, but they may lack the broader co-benefits seen in nature-based projects. Next on this list is technology-based carbon removal, a newer and rapidly evolving technology. Examples include, number 1. Direct air capture. In this, carbon dioxide is captured directly from the ambient air using chemical solutions or sorbent. Number 2. Carbon capture and storage. In this, carbon dioxide emissions are captured from point sources like power plants and factories. Number 3. Biochar, carbon in soil. In this, biomass produces stable charcoal that lacks carbon in agricultural soil, enhancing fertility through pyrolysis, which means heating biomass without oxygen. Number 4. Enhanced weathering. In this, crushed silicate rocks like basalt are spread on land, acceleration natural weathering which absorbs carbon dioxide. These technologies aim to permanently remove carbon from the atmosphere. They are often seen as high integrity and scalable in the long term, but they also face challenges such as very high cost, early stage deployment and limited current supply. Now it's time to compare the categories. Each project type comes with its own trade-offs, balancing cost, impact, and permanence in different ways. Nature-based solutions scale beautifully, but they face real risks when it comes to permanence. Renewable projects are proven and reliable, but they raise questions about whether they truly need carbon credit support. Methane emissions projects deliver big climate impact, but their scope is limited to sources like landfills and farms. Technology-based projects carry high integrity, but they come at a steep cost, making them expensive to scale. Which means there's no such thing as a perfect carbon credit. The value of a carbon credit depends on the type of project, how it is implemented and how it is verified. Understanding the types of carbon credit projects helps us see that carbon markets are not a single system. They are a collection of very different approaches to reducing and removing emissions. And each approach comes with its own strengths and limitations. Which is why evaluating carbon credits requires more than just looking at numbers. It requires deep understanding, not just of what's visible, but of what truly drives these projects behind the scenes. And now, we come to the closing segment, which reveals that understanding different types of carbon credit projects is only part of the story. The next question is asking how a project actually becomes a carbon credit. From project design and validation to monitoring, verification, issuance, and retirement, there is an entire process that takes place behind the scenes. In the next chapter, we'll follow the complete lifecycle of a carbon credit and understand how credits are created in the real world. Thanks for watching. See you in the next video, where we uncover how carbon credits come to life.